All right, now that we learned how to solve inequalities, now it's time to solve absolute value equations and inequalities. So if you see the outline of what we've been learning, we were learning equations first, solving for the missing variable. Then we are solving inequalities, also solving for the missing variable, but then your solutions are going to be a little bit more complex because you're going to have anything less than a number or greater than or equal to a number. So there's actually infinite solutions for those types of questions rather than an equation just having one solid answer. Now we are going to be moving on to a new concept, absolute value equations and absolute value inequalities. Unfortunately, because we're not in class, we're not going to be able to complete this investigation. So I am just going to just read the question and then read this, and then we're going to get right to the notes because this is like a group project which we won't be able to do in school. So what does the solution of an absolute value equation or an inequality look like on a number line? The absolute value for a number x, written, the absolute value of x, is the distance on a number line that the number is from 0. For example, the absolute value of x equals 2. The answers are both 2 and negative 2 because those are both 2 units from 0. So that means the absolute value of 2 is 2 and the absolute value of negative 2 is 2. So if we look here on this number line, we can see both negative 2 and positive 2 are 2 units from 0, which is why there's 2 answers for that. We're going to skip all the way to the next page where the actual notes start for section 2.5, absolute value equations and inequalities. So we're going to start with equations and get the hang of how to solve these, and then we'll solve absolute value inequalities, which are a little bit more difficult. So an absolute value equation may have one solution, 2 solutions, or no solution. So A says the absolute value of x equals 3. What this is saying is what value will x be so that the answer is 3 units from 0. Basically, whenever you have the absolute value of the variable on the inside, you're going to have 2 answers. Think to yourself, what number is 3 units from 0? Your first thought is probably 3, and that is one of the answers. But then the other one is going to be the opposite of that number. The absolute value of x equaling 3 could also be negative 3, because both 3 and negative 3 are 3 units from 0. So these solutions would either be 3 or negative 3. Now, you don't have to write x equals 3, x equals negative 3. There are other ways you could do it. You could just write x equals 3 comma negative 3. Using fancy brackets like this, you could write 3 and negative 3 like that. That's a fancy way to write it. You might see that later on in your math career using these fancy brackets. Basically, however you want to write your answer is fine, as long as I can see you understand how to find the answer and what the answer is. Okay, the next one is asking what number would be 0 units from 0. So what's the absolute value of x equals 0? Well, there's only one number that is going to fit this category, and that's just x equals 0. Since there is no opposite of 0, 0 is its own type of number where it doesn't have an opposite, so this only has one solution. Notice A had 2 solutions, B has 1 solution, and C says the absolute value of what number is equal to a negative 1. Well, remember, absolute values always equal a positive number, because when you take the absolute value of something, it takes it and spits out a positive number because it's representing a distance, and distance is always positive. So you cannot have the absolute value ever equal to a negative. This is considered no solution. Notice, though, that your answers to absolute value equations can be negative numbers, because these negative numbers, when you put them into the formula, spit out a positive answer, but the absolute value can never equal a negative number. There is no number I could put in for x that when I take the absolute value of it, it would equal a negative 1. It's impossible. So in example 2, we're going to be solving absolute value equations. So before you can solve absolute value equations, you must isolate the absolute value expression to be in this form. absolute value of ax plus b equals c. So that means basically you have to isolate the absolute value bars first, and then once you have those isolated, then it's time to solve them. So in letter A, we have the absolute value of x plus 5 equals 7. These absolute value bars are isolated. That means there's no number being added to it or subtracted from it. There's no number being multiplied or divided. It's just the absolute value of x plus 5 equals 7. To solve these types of equations, you split them up into two separate equations because there's usually two answers for each absolute value question. And what you do is you drop the absolute value bars and you just write x plus 5 equals 7 as one of your equations. Because what's inside the absolute value bars is x plus 5. And x plus 5 can equal 7, or x plus 5 can also equal negative 7, since the absolute value of negative 7 will also equal 7. So basically you split it up into two equations. I know that in order for the absolute value to equal 7, the answer on the inside can either be 7 or negative 7. So what you do is you split it up into two equations. X plus 5, the middle stuff, equals 7, and x plus 5, the middle stuff, equals negative 7. And then you solve these separately. Well, if I subtract both sides by 5 here, I get one of my answers is equal to 2. And if I subtract 5 here, I get my other answer is negative 12. It's really helpful to take your answers and replace them in for the variable to see if it's true. Well, let me put 2 in for x here. 2 plus 5 is 7, and the absolute value of 7 equals 7, so that's correct. Let's use negative 12 now. Negative 12 plus 5 is negative 7, and the absolute value of negative 7 is also 7. Let's try b next. This says the absolute value of 2x minus 1 and then plus 3 on the outside is equal to 8. Our first step before we start solving anything and like splitting them up into two equations is we have to isolate the absolute value bars. This plus 3 on the outside here needs to go away before I can split anything up. So my first step is subtracting both sides by 3. When I do that, I get the absolute value of 2x minus 1 is equal to 5. Now this is considered isolated. The absolute value bars are now isolated. There's no number being added to them, subtracted, multiplied, or divided. So we are ready to split it up into two separate equations. This stuff on the inside here, the 2x minus 1, can equal two numbers. This can equal 5 because the absolute value of 5 is 5. And the stuff on the inside can also equal a negative 5 since the absolute value of negative 5 is also 5. So that's where the thinking comes into play from splitting it up into two equations. So 2x minus 1 equals 5 is one equation we will solve, and 2x minus 1 equals negative 5 is the other equation we will solve. For both of these problems, we're going to complete the two same steps. Adding 1 to both sides, I get 2x equals 6. Dividing by 2, I get x is equal to 3. This is one solution for this problem. Similarly, adding 1 to both sides, I get 2x equals negative 4. Dividing by 2, I get x equals negative 2. And it is nice to just be able to take your answers and replace them back in to make sure it works. And I will take the time to do that so you can see and believe that this is why we do this. So let me replace 3 in for x. So right here, I'm going to replace 3. 2 times 3 is 6. 6 minus 1 is 5. The absolute value of 5 is 5. 5 plus 3 is 8. That's how I would solve that using the order of operations. So I'm good. Now let me try negative 2. I'm going to put negative 2 in here for x. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is 5, and 5 plus 3 equals 8. So we're good to go. What I want you guys to do now is please pause the video, try C and D on your own. Don't forget, the first thing you have to do is isolate the absolute value bars if they're not already isolated. All right, now it's time to go over C and D. Letter C, the absolute value bars are already isolated, so I can start by splitting it up into two equations. 3x plus 4 equals 10, and 3x plus 4 equals negative 10. My first step in these problems is subtracting both sides by 4. I get 3x equals 6, and then when I divide by 3, I get x equals 2 as one of my answers. The next one, subtracting both sides by 4, I get 3x equals negative 14. This answer is going to just be not as friendly. When I divide both sides by 3, negative 14 divided by 3, I get negative 4 2/3, or if you wanted to leave it as negative 14 thirds, that's fine. Or negative 4.6 repeating. Any of these answers are correct. They're all representing the same exact thing. So those are your two answers for that one. Moving on to letter D, the first thing I have to do is isolate the absolute value bar. So that means I need to get rid of this 10 by subtracting both sides by 10. When I do that, I get the absolute value of 2x plus 6 equals a negative 4. As soon as you see a negative sign over here on the right, you should automatically think there's something wrong here, because I can never have an absolute value ever equal a negative. So this one's actually nice because the only thing I had to do was subtract 10 from both sides, and I realized quickly this is no solution. So that was solving absolute value equations. In example 3, we have some more practice problems with solving equations involving two absolute values.